Okay, welcome back to lesson 3.3. This is part 2. We talked about the operations on functions, so now we're going to talk about composition of functions. This is where we start to combine our functions and taking it to a new level. I had f of x and g of x. Now I'm going to see what happens where I substitute in the function g of x into the f of x function. What does that change about it? And the same thing. What's going to happen if I take f of x and substitute it into the g of x function? So let's take a look at example 3. F of x is equal to 2x to the third power, and g of x is equal to x to the negative first power. Okay, so example A says f of g of x. So we are going to take the f of x function, preferably once we have a marker working. There we go. We are going to take the f of x function, and what we're going to do is substitute in the g of x function, which is x to the negative 1, in for x in the 2x to the third power. So I'm going to take out just plain old x, and I'm putting in x to the negative 1. This is what g of x is equal to. And then that's to the third power. So notice if I had said f of 2, you would take out x and put in a 2 and evaluate. Here, I'm saying that f is equal to whatever g of x is equal to. So then we're going to substitute, or we're going to simplify this out. So I have a power being raised to a power, so we're going to multiply. So that means 2 times x to the negative 3. And then we want to simplify. So this needs to be in positive exponents. So h of x is going to be equal to 2 over x to the third. Notice that the 2 is separate from the x to the third. If I wanted them together, they would be in parentheses. If they're not in parentheses, the 2 is not part of that exponent. All right, let's take a look at example B. This time, I'm saying that g of x is going to be equal to whatever g of f of x. So my g of x formula is x to the negative 1. Well, in place of x, I'm going to put in whatever f of x says. So f of x is 2x to the third. So that's being taken to the negative 1. Again, I want to distribute this negative 1. Now notice that this time, the 2 is inside the parentheses. So when I distribute that power, then yes, it's going to be included in the exponent. Same thing for the x. It's going to go to both. Or, maybe a slightly easier way to think about this is a negative exponent. That means everything needs to move to the denominator. And there you don't even have to worry about distribution. I could have said 2 to the negative 1 times x to the negative 3, and that just would have meant 1 over 2 times 1 over x to the third, which simplifies back to 1 over 2x to the third, which is what we got anyways. So sometimes think about what's happening with your rules, and it makes it a little bit easier. Now this strategy of composition, where we're combining functions within other functions, it's a little bit different. Tomorrow in class, this is probably what we're going to spend a lot of time on, is how we go through this process. And again, it's just about being conscientious of what's going where, how you're doing it, and then making sure you simplify according to the rules of distribution and exponents and things like that. Let's take a look at a word problem. So how would these problems be asked of us with a word problem? All right, you purchased water skis with a price tag of $180. The sports store applies a newspaper coupon of $50 and a 10% store coupon, or store discount. Use composition to find the final price of the purchase when the coupon is applied before the discount. Or use composition to find the final price of the purchase when the discount is applied before the coupon. So it's about the ordering of your discounts here. So let's take a look. The first thing that we want to do is we want to write out the functions. What's happening to the price in each scenario? One is we're applying a discount and one is we're applying a coupon. So of course, X is going to represent the sales price. And I know that it gives us the sales price in the coupon, but thinking about it in terms of functions, we need to have a variable here. So the first function, let's just call it f of x, why not, is what's going to represent the coupon. So let's put coupon here. Okay, so the price minus the coupon. Well, the coupon is $50, so x minus 50 represents the coupon price. Now, the discount, if I were taking these separately, right, we'll call that g of x, would be the price minus whatever discount, which is 10%, so 10 hundredths times x. And if we simplify that, it means really what's happening is we're paying for 90% of the price. We're paying 90% of whatever the value was, because we took 10% off. So the discount is represented by g of x. So our first scenario says, well, what happens if I use the coupon first and then the discount? So our composition is a little bit different. We're going to take 90% of the coupon price. So the price after the coupon is what we take 90% of. When I was doing up the work for this one, I honestly found it easier to solve the problem and then match up which letters were going with it beforehand. It was a little bit tricky. I knew that I wanted to find the price after the coupon, so that's the x minus 50, and then I was going to take 90% of that, and that would be what the final answer is. Now, if you want to, you can simplify that, but I chose not to. I went ahead and just substituted in 180, subtracted 50 to get 130, and then multiplied that by the 0.9 or 0.90, however you want to say it, and that gave me a price of $117. Again, use your calculator, makes things much easier. And this is what happens when we apply the coupon first. So coupon first. What happens if we're going to apply the coupon second? Let's do the discount first. So what we would want to do is figure out what is the price of the skis after the discount, and then we're going to take $50 from that. So step one, instead of x minus 50, we're going to say 90% of x minus 50. And when we substitute this in, figure out what 90% of 180 is, and then subtract 50 from that, and you would get your sales price, which in this case is $112. Again, at any point if you need to, certainly feel free to pause the video, look over the work, maybe listen to it again a couple of times, and then when you're ready, move on to the examples. I'm going to go ahead and erase this. Now I'm going to pull up your practice problems. Practice problem number 5. Go ahead and do the compositions. F of x is equal to 3x squared, and g of x is equal to x squared plus 5. A little bit trickier than what we did in the example, so think through what's happening and how you substitute in the values. In example 6, all you're doing is reworking our water ski example from example 4, but this time our price tag is $200, the coupon is $30, and the discount is 20%. So what is that going to change for our values? Remember, there's 2 parts to this. The first part is what happens if the coupon is applied before the discount, And then the second part is what happens if the discount is applied before the coupon. In the real world, generally speaking, coupons are taken off first and then percents taken off next. When you're ready, move on to the next slide, press play. All right, and here are the answers to the two practice problems. Again, any that you have questions about, circle them, make a note on it, and be sure to ask about it in class tomorrow.